Today I'm going to tell you about a fun and smart robot that we are going to build. It's called an obstacle avoiding robot. This robot can see things in front of it using special eyes called sensors. If something is blocking its way, then the robot won't hit it. It will quickly turn left or right to find a free path and keep moving. Let's fix 3 IR sensors, that is infrared sensors, one on the left, one in the center and one on the right, using a 12 mm screw and a nut. We will be using motors, motor driver shield, a brain called Arduino to help it think and move. First, let's remove the top plate. And connect the 3 IR sensors to the left sensor, VCC pin of sensor to +5V pin of the shield, GND pin of sensor to GND pin of the shield, out pin of sensor to A0 pin of the shield, center sensor, VCC pin of sensor to +5V pin of the shield, GND pin of sensor to GND pin of the shield. Out pin of the sensor to A1 pin of the shield. Right sensor. VCC pin of sensor to 5V pin of the shield. GND pin of sensor to GND pin of the shield. Out pin of sensor to A2 pin of the shield. Now fix top plate to the middle plate using 10 mm screws again. And tighten with the screwdriver gently. Now let's upload the code which tells the robot what to do. So for this, let me connect the robot to the laptop with the dumb cable. So this is how I connect the dumb cable to the Arduino. Now let's upload the code which tells the robot what to do. So for this, let me connect the robot to the laptop with the dumb cable. So this is how I connect dumb cable to Arduino at USB port of my robot. To USB port of my laptop. Now open the code file. The first thing we have to do is choose select board option and click select other board and port option and search for Arduino Uno and select it. And in ports menu, select the available port. Now look into the code and let's start with setup function. Here we define the 3 IR sensors pins. A0 for the left sensor, A1 for the center and A2 for the right. These are set as input pins. Since they receive signals from the IR sensors. Before setup, we create 2 more objects using Adafruit Motor Shield library, Motor 1 and Motor 2. In the loop function, we continuously read the values from the IR sensors using digital read. These values are stored in variables LS, CS and RS for the left, center and right sensors respectively. The core logic of obstacle avoidance is based on different combinations of sensor readings. If all 3 sensors detect no obstacle, meaning they all read high, and the robot moves forward. If the left sensor is low, indicating an obstacle on the left, the robot turns right. If the right sensor is low, indicating an obstacle on the right, the robot turns left. If the center sensor detects an obstacle, the robot reverses for a short duration, then turns either left or right to avoid it. The robot also handles complex cases like obstacles on 2 sides or completely surrounded by reversing and trying a left turn. Now let's look at the movement functions. Forward makes both motors run forward at speed 150. Reverse sets both motors to run backward at the same speed. Lift spins the robot to the left by running left motor backward and the right motor forward. Right does the opposite to turn right. Additional functions like stop left and stop right are defined but not used in current logic. They can be used to stop or make sharper turns if needed. So let's verify it by hitting the tick button. And upload the code to the Arduino by clicking on the right arrow button. Now let's check how our obstacles avoiding robot actually works. When the robot is moving and sees something in front of it, it says, "Oh no, something is there, I need to turn." So it turns to the side where there is no obstacle. This simple yet effective code allows the robot to navigate its environment, detect obstacles, and make real-time decisions to avoid them. You can customize more speed and delay values to tune the behavior of your specific robot and environment. And that's how my smart robot avoids obstacles and keeps going. Thank you for watching, and I hope you liked my robot.